So this is a year of 2024, and the question is, why do we even need to think of Kubernetes anymore? There's so many various SaaS services available today that can get you going in a matter of minutes. Whether you're a small company or individual user, there must be something there for you. But the truth is, there's always gonna be hidden costs that you didn't quite consider in the first place, and that in turn could get you quite surprised with a hefty bill later down the road. And that is all because your business might have grown a lot, and as such, utilization of the services that you rely on. And it's also very hard to tell whether your sales are gonna considerably outgrow the expenses you bear that are associated with those SaaS services. But I assure you, if you solely rely on SaaS providers to do your job, there is always gonna be a potential to optimize costs, whether by doing things yourself or by switching in between various SaaS options. And just to prove myself, I'm gonna give you this. You could probably put yourself into investor's shoes, who's putting his money into those companies, so that you could ask yourself, what is that really is that you're after? Well, you'd probably wanna go after revenue, but then how? One of the ways to maximize your revenue is to tie it up with your customers' revenue, so that you benefit along with the success of your customers. That's exactly what they're doing by introducing all those tiers and replenishable credits and unnecessary complexity. But we're gonna do much better than that. To address those concerns, we're gonna be doing Kubernetes in 2024, and here's why. Kubernetes is known for its complexity, but also for its flexibility. So having your system hosted in there is gonna give you portability to not depend on a particular underlying service provider and easily switch between those at will. There's so many various things you can manage about Kubernetes, but the good news is that cloud providers have actually done the great job of automatically managing most aspects of it. Kubernetes has matured a lot lately, so it's gonna give you pretty damn good stability, reliability, and auto-scaling to fit your ever-growing needs. There is a bunch of integrations available on the cloud side, and you can even do things like cross-cloud orchestration these days. They also offer great transparency through various observability tools, and some offerings even enterprise ready from the get-go. And the final and most important piece, which what we actually are aiming for, is cost efficient, so that you can really benefit of the scale cloud providers have gotten to in various ways. I'm gonna tell you how exactly you do that. We've got a couple of options of managed Kubernetes distributions by major cloud providers available in different modes. We're gonna go through all of them, and I'm gonna tell you how they differ in terms of available features, amount of effort involved to implement it and maintain it afterwards, and also, most importantly, the costs associated with that. The first thing on our list is this Amazon Elastic Kubernetes service. I've opened up this overview page that contains some high-level overview, what that is, and accompanied by this useful charts showing available modes. That's what we're going to be essentially talking about. The EC2 mode, where your worker nodes are hosted as virtual machines by AWS, and Fargate, which is essentially a serverless option for your containers. It also supports Outposts, essentially hosting your cluster on premises or on this extended cloud infrastructure on premises, and anywhere which you could think of as your cluster being extended to other public clouds. Let's go through some of the EKS features Amazon has mentioned on its website, and it's gonna give you a fairly good understanding on what it's all about. And the first thing in our list is this manage control plane, and trust me, you don't want to deal with that. You don't want to manage a control plane yourself. It's not a straightforward process. Let AWS do the hard work. Once you deploy this EKS managed service, you're going to receive this Kubernetes API endpoint through which you can interact with your cluster, either using command line tools like kubectl or using visual tools like Lens, for instance. But AWS also offers this console experience, so you don't have to ever leave the console and continue working with Kubernetes. It's all there now, right? And things like authentication are taken care of. You can do things like deployments, configuration management, networking setup, troubleshooting, all right there. It's quite convenient. EKS add-ons is a big deal because it can easily allow you to integrate with AWS ecosystem for networking, observability, permissions. With virtually just a click of a button, you'd be able to install those system services in your cluster, and they will do all the work for you. And another important operational category you should be thinking about when it comes to Kubernetes is how the heck are you going to manage worker nodes, right? Well, you don't have to. AWS has this manage node groups capability, which are basically representative of worker nodes. And it's just much simpler process by itself, right? You can create those via EKS console or API or using corresponding tool like Terraform, and they're there, connected to your cluster, visible in the console. Lives is good, right? Another good thing about it is that they work with Spot instances, which can significantly reduce your costs given the self-healing nature and auto-scaling capabilities of Kubernetes. It can save you tons of costs. I will talk about it in a second. One more thing when it comes to workers is that with this thing, you don't even need to think of workers anymore, because AWS has this service called Fargate, and that is known for container orchestration. So you send a Docker image and specify a couple of parameters and it schedules a workload right there without needing to think about virtual machines or things of that nature. So there is an integration now in between EKS and Fargate that allows you to continue dealing with Kubernetes in the same manner, just specifying some deployments, networking, configuration management, all that. And it schedules a workload right to Fargate, so no nodes are visible EKS console whatsoever. Quite convenient and quite expensive, and we'll get to it in a sec. AWS also has a comprehensive documentation on the topic, including things like EKS architecture with main components that cover operational aspects of it as well, for instantiating your first cluster, attaching nodes to it, configuring it in a serverless manner, setting up observability, networking, storage. They have troubleshooting guides and things of that nature. AWS also has this tool called kubectl, which is a command line tool allowing you to manage the cluster from command line and as such script it out and automate the process and propagate it onto other environments. Quite convenient. It's capable virtually of everything I've just mentioned. It exposes a set of operations you can pair it with, specify additional arguments that'll do the work in the best way instead of doing it as a multi-step process. When it comes to the pricing, you gotta understand two important pieces here. First, there is a flat management fee of 10 cents an hour that translates to about $75 a month, and that covers your control plane that is a part of a cluster, right? As long as you have your cluster on, you're gonna have to pay the amount anyway, and there is no discounts, though you can use AWS credits towards that. Another big contributor that goes towards your overall cluster costs is your compute environment, for which you can use managed nodes with virtually any type present in the entire AWS ecosystem, and this is the largest one, I think. They have very many various instance types available for different use cases. You can see on the left side of this page, they have Intel-based instances, ARM-based instances. They have their own special Graviton instance that shows the best price-performance ratio. One of the great things to do with Kubernetes is to use it with Spot instances, because Spot instances are known for great discounts up to 90%. And it's all given to you at the expense. You can take this instance out of service at any point of time, whenever they need this capacity back for on-demand usage. You never know when. But Kubernetes is known for handling those situations very nicely, provided you configure this underlying platform properly. And another good thing you can do is that you can assemble fleets, instance fleets. You can do it with on-demand instances as well as Spot instances. Say if a demand for a particular instance type is very high, so will be the price for it. And you want to avoid that situation ideally. And what you do is that you create this fleet and you select as many instance types as possible that fit your case, and the system will intelligently choose the instance type with the lowest price at the moment to provision for your cluster. You also have a couple of configuration parameters and policies to control various aspects of that behavior. And you can also combine on-demand and Spot instances in a single fleet for the best resilience and cost efficiency. It's always important to remember that you can always schedule your workload for Fargate, and if you do that, a corresponding pricing policy will apply, where you're actually paying for CPU hours and gigabyte hours, and if you have replicas, this thing will multiply. There's only so many configuration options supported, which means you gotta choose out of these combinations of CPU and memory to size your workload, and that's gonna translate to a certain amount of cost associated with it. That means that there's always going to be a minimum cost. You can go lower than that, which is different from a regular Kubernetes where you can actually take advantage of this extra capacity that exists in the cluster all the time. Another thing to consider when it comes to the pricing is savings plans, and those require commitment up to 3-year term, can reduce your overall costs up to 66%. It works for regular instances as well as Fargate. The commitment is going to be in different terms though. For Fargate, gigabyte hours, CPU hours. For instances, it's going to be usage of a particular instance type for a long period of time. Off we go to GKE now, which is my favorite, but no bias in here. We're gonna talk objectively to make it the most useful for everybody. They support a bunch of features in here, offering different automation options, managing more aspects of your cluster lifecycle, with a goal to lower total cost of ownership. They have various editions, a standard one that has existed forever. They have a new edition, Enterprise. They just presented it last year in this annual Google Next conference in San Francisco in September. This one focuses on like collaboration, teams, activities, better security, better compliance, things of that nature. That is for bigger corporations, but a spoiler alert, we would even be able to benefit out of it. They have this Autopilot version, which is an alternative to AWS EKS Fargate with per pod billing. They cover networking and storage and back it up with a special driver for efficient communication. And they have this advanced autoscaling that scales up to 15,000 as opposed to a regular 5,000. Since you're focusing on the pricing, it's really going to depend on the edition you choose to go with. There is a standard one with a pretty much same fee we saw in AWS, but as opposed to AWS, Google actually covers a single zonal or autopilot cluster a month in its free tier, right? Zonal means less resiliency because the control plane exists in a single zone. So if a zone goes down, so does your cluster, but it's good for developing anyway because it's given to you for free. Once you're done, you move it over to a proper cluster. Autopilot has a little bit different pricing model. They charge you for pods, their sizes, okay? Enterprise deserves attention because the pricing model here is sort of like the same. They're charging for the total amount of CPUs allocated to all of your pods in total. And that means for smaller clusters, it's actually going to be cheaper than you paying for a standard cluster. And they're also giving you like 90 days period to try. When it comes to Autopilot, seems like there are more rules than freedom. As with Fargate, there's a minimum amount of resources you can specify for your workload to use. You can get lower than that, and that would dictate the minimal cost of hosting this workload, which is different from a normal cluster where you can actually leverage an excessive capacity for your workload to run on. There are also various instance types available, though the choice is not as great as AWS offers, though we can work with it. There's like a shared instance types, the cheapest one, 10 times cheaper approximately than a regular, normal, general purpose instance. Similar to AWS, Google also has a Spot VMs, which can get you up to an 80% discount. Total price might be even lower than in AWS, and it might be a little bit counterintuitive because how come, right? Google has less instance types available. Google just consolidates more CPU architecture under a single type. They just like committing to a single type, having like a bigger pool of available instances of that type. And that means that your instance is likely going to be interrupted less often for the same reason. Similar to AWS, Google also offers its committed use discounts that can result in good cost savings over the extended period of time. They come into different flavors, resource-based and flexible. Resource-based will take you to commit to use a particular resource like an instance type in a region for a year or 3 years, whereas flexible is just a commitment to use certain amount of CPU or memory over minimum number of hours a day. There is another page where they have a bunch of summary tables where they compare prices of different machine types for on-demand, spot, and committed use discounts. But I'm actually going to come up with a bigger table in the end to compare options across cloud providers. The last item in our list is this Azure Kubernetes service. We're going to go through this marketing page and see what features they highlight and how they differentiate the offering from the alternatives. Evidently, they are putting a stress on getting started, provided that the audience is aware of what Kubernetes is in general. They offer these default presets to get started with very easily so that you don't hesitate to deploy your cluster by offering you some default options. They have this fascinating tool called Draft, and that is going to allow you to migrate your legacy application onto Kubernetes, generating all necessary manifests and specifications. They have this fancy autoscaler, which we'll discuss later, and a marketplace to allow you to install things off of the marketplace directly into your cluster. Since it's a Microsoft and Microsoft owns GitHub, and that we all know that how open source community loves GitHub, well, Azure, for that reason, backs up their CI/CD pipelines with GitHub Actions with a seamless integration. They also offer integration with Visual Studio Code, which is a very popular code editor these days, and they offer great observability into the deployment process. A few words about this fascinating autoscaler called KEDA that has been considered to be a graduate project by CNCF. Has a pretty much straightforward architecture, and the purpose of this KEDA is to scale your workload flexibly by horizontal pod autoscaler down to 0 if necessary, based on the external events and systems this workload integrates with. Those systems include various Azure services as well as services by other cloud providers, things like data stores, message queues, buses, and things of that nature. They have these presets available for you to get started with. Whenever you're ready to deploy your first cluster, you're going to be offered this choice. Most likely you're going to start with these dev test configurations, this cheapest one, to get comfortable with Kubernetes overall. And then at some point, once you have a service running, you're going to switch over onto the production economy or production standard if you need more resiliency. It's all going to depend on the number of users using your services though. Which brings us to this pricing page, where I would like to highlight that there are 3 tiers available, including this free tier similar to Google, which you're not paying anything for, though you're not limited to just a single cluster, can have as many as you want. The number of nodes is recommended to not be higher than 10 due to, I guess, some limitations, how big of a control plane is. Though the good thing is that it includes all of the current features, which would definitely serve you well in terms of testing it out properly before going to the standard tier, where they've got you back offering SLA guarantees and very good auto-scaling capabilities as well. As other cloud providers, they also offer a savings plan, and the way it works is that you commit to use a certain amount of resources for a number of hours a day, and if the usage is lower, you're not really saving much, you're still going to have to pay for it. But then if you utilize it more, then it's actually going to result in a lesser rate for those resources. And the alternative to committed use discounts would be Azure Reservations, which offers a reduced price for using virtual machines up to 72% in savings. They also offer the same thing for other managed services such as database and data stores and their container orchestration app service. They also have this Spot offering, which I already explained what that is, but they have it for their instance types, the demand for which is different from other clouds, and so is the price rate. What's going to be useful is to compare actually all cloud provider options side by side, and let's do it now. We're going to start with comparing control plane rates or so-called management fees, where I'm going to repeat myself saying that virtually every cloud provider has the same flat fee of 10 cents an hour for a standard offering. With Google, you can also have this free zonal cluster. In Azure, you can have a few of those. Google has this enterprise offering where they charge for a number of total CPU allocated across all of your pods in the cluster. Azure also has this enterprise offering, but they pretty much follow the same pricing model, which is a flat fee, though it's 6 times higher than a regular standard fee. When it comes to per pod billing, AWS offers a little bit better rate, that is 15% lower than what Google has. But with Google, you don't have to stick with a particular configuration presets, which allows you flexibility to not overspend for stuff. When considering compute, things are getting really interesting because according to my research at the moment of this recording, AWS is at least one generation ahead over other cloud providers. They offer these Intel Sapphire Rapids for even a lower rate than the previous CPU generation, though this is a flex version, which is a little bit of a stripped out version of an instance without those fancy features that will still offer you a great performance exceeding the one coming from the previous generation that will fit certain scenarios. But even if we compare the same generation of processors with instances of a same size, we will see that AWS is still a winner here, offering the better rate amongst all cloud providers. And the second place goes to Google. Azure is dragging behind. Another thing to keep in mind is the spot rate, because this is where AWS does not shine in any way compared with other cloud providers. It might have to do with the fact that AWS offers a lower base rate, so people are coming to AWS and making use of compute and switching over eventually onto spot instances. Drives the demand and the price up, I guess. So just keep in mind that with other clouds, you can probably do better if you set up your spot architecture properly. All cloud providers offer this burstable instance type, which is a perfect thing to start with because it costs just a fraction of a base rate for the same amount of resources. Those are burstable, so they can get throttled. You should not be worried about it because you're only going to be using them so often. They also hosted in a shared infrastructure. Should not be a big deal either because you're gonna be using it for developing and testing purposes. And to compare these various pricing models, I put together these setups for smaller cases. And as you can see, if you go with this autopilot per pod billing mode, so to speak, you're paying like a little bit of a premium every time. With GCP, it's even more than that because it costs more eventually for the smaller workload. But the cost efficiency, if you go with a regular node, is actually higher because there's going to be excessive capacity at all times, and you can also size your workload lower than necessary and allow it to burst, which is a great cost benefit as long as you can manage it this way and don't have to rely on the pod-based scheduling. Another thing to pay attention to in this table is this monthly cost for various presets of an arguably production-ready cluster and compare it between cloud providers. As you can see, things don't differ much when it comes to like regular on-demand nodes, whereas for the spot, AWS is definitely not in a great position here. So you have much more opportunity to save costs with other clouds there. So this is pretty much all I've got for you for today. We've just walked through all of the Kubernetes offerings by cloud providers, compared the prices of different pricing models, made sense out of it. The right thing to do now, if you are considering these for a smaller project, would probably be to go with GCP because they offer this free tier where you can gain some confidence and master the skills. They also offer this enterprise for 90 days for free. You don't need enterprise just to kind of see what's out there, the best practices, so to speak. And then if it works for you, fine, try Spot. Spot is cheap in Google. If you want to do things at scale, you may consider switching over onto AWS at some point, I think. That's where I want to stop. It's been a little bit of a research for myself, in particular could be useful for you, I'd be happy to hear that back. If any of it has been helpful, feel free to reach out to me. I'm on social media, Twitter, LinkedIn, and YouTube. Thank you so much for watching. Give it a like, leave a comment, and I'll see you next time.